Okay, so we are working on the problem of 1 kilogram bags of sugar. And the first question asked what proportion were underweight. So I guess I didn't mention it when I wrote down the question, but we're assuming that they're normally distributed. So the way we found things in the normal distribution, the easiest way was to go to graph and then probability distribution plot in Minitab. And we were choosing view probability. We have to put in our mean and standard deviation. So our mean was 1.03 kilograms for our first factory, and the standard deviation was 0.014. Flip over to shaded area, click the shaded area tab. And I wanted to know the proportion that were underweight. So first of all, I don't know. The probability and proportion are like basically mean the same thing. What is the probability that a particular bag is underweight? What's the proportion of all bags that are underweight? Those are asking the same question. So I don't know the probability. That's what I want to find. What I do know is the cutoff line for what I'm calling underweight. These are supposed to be 1 kilogram bags. Anything other one is going to be underweight. So I put in a 1 for my X value. That's the cutoff. And I want to find everything less than that. That is going to be to the left in the bell, the left tail. So X value of 1 is our cutoff. We want everything to the left of that, so we take the left tail. Hit enter. This is what we get. It looks like it's just under 2%, so 0.01606. That is the proportion of bags that are underweight. So not that many, less than 2% are underweight. The second part of the question was to find, basically, like I wanted to find an interval symmetric on this bell that would include 95% of all bags of sugar. So how far out do we have to go to the mean in both directions so that we get a chunk in the middle of the bell that has 95%? And then the remaining 5% is split evenly between the two tails. So we bring back our probability distribution plot, view probability. Same mean and standard deviation, we don't need to change those. This time I know stuff about the probability. I want 95% in the middle and 5% in the tails. So we have this option both tails, which splits the leftovers equally between the two tails. And that is the most convenient one for us to use here because we want 2 equal tails. And 0.05 is in here. That's maybe what the default was that Minitab entered, and that happens to be exactly what we want. There's 95% in the middle of the bell. The shaded part in this picture are the two tails, so we need to know how much is in the two tails. We have 5% left over to be split evenly between the two tails. If we chose middle, if you do middle, you still need to know what's in the tails. So we could say that there's 2.5% in each tail, but that's more work. Let's choose the both tails option. So probability, we know there's a certain probability we're looking for. It's 95% in the middle. Because of the way Minitab is set up, it actually wants us to tell how much is in the two tails split evenly, so 5% split between the two tails. I think we're set up here, so we hit OK. So there's 0.025 in each of the tails, and it looks like we want to go from 1.03 up to 1.057. So it looks like 0.027 kilograms, both up and down. So we go up 0.027 kilograms and down 0.027 kilograms. And that will give us a middle of the bell that covers 95%. So the answer to the question, find the interval is from 1.003 kilograms up to 1.057 kilograms. That covers 95% of bags of sugar. Okay, the last part was to repeat the proportion underweight question, but with a different mean and standard deviation. So probability distribution plot, we sort of do the exact same thing we did for the first part of the question, but now with a mean of 1.05 and a standard deviation of 0.016. So The mean is slightly higher, so you would expect like more of them to be over 1 kilogram, because the average is like even further above the mean, but there's a bigger standard deviation, so the bell is going to be more spread out. So that's going to sort of counteract the fact that we're moving the middle of the bell to the right. So I don't know if this is going to give a proportion under 1 kilogram that's higher or lower than the other one. So we repeat what we did before. X value 1, left tail. We want everything lower than 1 kilogram. Okay, that is very low. All right, 0.000889. And before it was like between 1 and 2%. This is well under 1%. So even though the standard deviation got bigger, I guess it only got a tiny bit bigger, but the mean went up. The mean went up a lot more than the standard deviation went up. The mean went up 0.02 kilograms. The standard deviation went up 0.002. And that made a difference. So standard deviation didn't really change enough. The whole bell moved significantly to the right, so the tail that was under 1 kilogram got a lot smaller. Okay, so we'll do a second, we'll move to a new video to do our second example.